Go. Hi, everybody. Welcome to another episode of Continuous Discussions, the online forum where we talk about Agile, DevOps, and continuous delivery. I'm Sam Fell.
And I'm Anders Wahlgren. And today's topic is continuous testing. And we're going to talk about the difference between continuous testing and just plain old test automation. We're going to talk about some of the challenges with continuous testing. And of course, some of the key prereqs for doing this well and patterns for success in this area. And as always, we've got a fabulous panel of experts, and Sam will now introduce them for us.
Very good. And the names are going to be awfully confusing, so we're going to just make up random names for people. So Andy Mann today, I'm just going to call you Man. So hey, Man, how you doing?
Hey there, Sam. Doing great, mate.
Introduce yourself, please, Man.
Sure. So Andy Mann, I'm with Splunk, Chief Technology Advocate. I work with customers to help them understand new technologies and how to implement, how to get more out of their IT. I also work with our internal people at Splunk, helping them understand what our customers need and building new products. And so, yeah, the continuous thing, I'm all about it.
Very nice. Awesome. Well, it's great to have you back, man. Andreas Andy Grabner, welcome back to the program.
Hey, thank you. And sorry for adding to the confusion with the names. I know my name is Andreas, but I think as I explained the other time, people typically call me Andy unless my mom calls me Andreas if I did something rude. I work for Dynatrace. I am a DevOps. I call myself now a DevOps activist because I want to get people excited about DevOps. I work for a technical team within Dynatrace to figure out in which direction we need to go, but really help the community to figure out how to do things like shifting left performance, shifting right metrics, and basically using metrics to deliver better software faster. And happy to add to the discussion today.
Fantastic. I love it. Thanks for joining us. Arthur Hicken, longtime friend of Electric Cloud. Welcome to the program.
Thanks, Sam. Glad to be here. I'm Arthur Hicken. I work with Parasoft. I'm also known as the Code Curmudgeon, and you'll figure out why by the time we finish this discussion. But I'm the evangelist here at Parasoft, and kind of like the activist, I'm here trying to help people improve what they're doing so that we can have better software.
Awesome. And we seem to have lost Sam, and we lost me as well. I had Chrome crash on me, and
Chrome just crashed on me too. Did
That's
Chrome
weird.
crash on anyone else? It like sent out a spike of bad.
yeah,
That's weird. Okay, thank you.
spooky crashing at a distance.
Just weird. Our quanta are entangled, Anders. Arthur, I'm assuming you finished. Thank you very much. Welcome to the program. Javier, welcome.
Hello, I'm Javier Delgado. I work at Stratio. It's a big data company, and I try to struggle to deliver our product in a continuous way that involves continuous testing, and hopefully every of our customers.
Can you guys hear me?
Yeah.
I can hear you.
Okay, so
We lost Javier.
yeah, his quanta now has become entangled, unfortunately. So he'll come back. Jeff, welcome to the program. Nice to see you again.
Hi, thanks. It's good to be back. I'm Jeff Susna, consultant. My company is Engineering IT, and our focus is really on bringing together Agile and DevOps and design thinking, and helping companies go beyond just building digital products and weave agility and empathy and continuous learning into the entire fabric of their organization.
I love it. That's fantastic. All right, so Javier, you're back. You want to finish? Are you back? He's not back.
No.
That's an artifact of him. That's like when he gets sucked into the black hole. There's this print of him that'll live forever, even though, and for him, it feels like we're just all here still doing our same thing, but we're not. So anyways, that's pretty deep stuff. I'm trying to find my presentation. All right, so let's get into the topics and start discussing continuous testing. What is continuous testing? How is it different than just test automation? And where does it fit in the process? Why would it fit in the process? Let's go ahead and start. We'll start, Jeff, with you since you are on my screen.
Okay. Rats, I was hoping to go last.
I'll have you go last next time.
All right. Well, I think in my mind, there are two levels to think about continuous testing. One is as part of the development and deployment, technical IT pipeline, but I think it actually starts before there. And I think that the world we live in now, we have to think of continuous testing as our approach to the whole business. And if you look at things like design thinking and lean UX, they're really about continuous testing in the sense that you have this great idea and you think you're empathizing, and then you have to go and you have to do some user testing, or you do an MVP. I've had lots of fascinating conversations in the last 24 hours about what the heck an MVP is. But really what it's about is testing your assumptions. And then that kind of flows into the technical pipeline. And the way that I like to think about things like DevOps is it's actually allowing us to test our assumptions even better, because we can find out in the real world with real customers using real systems, which is actually the only way you can truly know whether what you did is working or not, is to see how people are actually using it.
So let me ask you this. I'm going to challenge you a little bit. Is continuous testing deploying something directly into production? Is that continuous testing?
Well, I think that continuous testing is continuous kind of all the way along. So, you know, if you look at the design thinking and the MVP approach, you may test before you actually ever build it. And depending on the results of your test, you may never build it. As far as continuous delivery and continuous deployment, oh gosh, I don't know. I try and avoid that that particular conversation. I think, to me, the key is how do you find out as quickly and continuously as possible? And that may or may not involve actually deploying code into production immediately after it runs through some Jenkins pipeline. Right. And I think that, to me, that distinction for most organizations isn't that helpful, because a lot of companies have a long way to go before they're ready to do continuous deployment. So what I tell my clients, oh, help us do continuous delivery. And I say, well, what I'm going to help you do is to do more continuous delivery, to shorten the cycle. And if right now your cycle is 3 months, don't make it 3 hours and make it 3 weeks. If your cycle is 3 weeks, don't make it 3 hours and make it 3 days. So I think it's a continuum. And that's a long-winded way of saying, because I'm a consultant, it's the only thing I know how to say, is it depends.
It depends. I love that. That's the best answer. Although I'm learning with my kids that I actually can't say it depends anymore. I just have to say no. and then surprise them later if I change my mind. Because if I say maybe, then they'll never shut up about whatever I said maybe about. So there you go. All right, Jeff, thank you very much. Let's go to Andreas Grabner. What are your thoughts on continuous testing? What is it and why is it?
Well, I think I like what Jeff said earlier. I like the continuous experimentation aspect, because I think that's actually what it is, right? You have a thesis, and then you want to experiment on it, and you want to figure out, this is something people really like. I actually don't like the word continuous testing itself, because I think testing is so much, at least in my mind, something we do early on, before, more from the technical side, before we actually give something to our clients. And I believe what Jeff was explaining earlier is more this continuous experimentation, a continuous innovation, where you come up with an idea, and then there's different ways of testing that idea. And it could involve prototyping, it could involve real production testing, and then through A/B testing, through blue-green deployments, you basically get feedback on whether what you're doing is actually good or not. But then it also involves obviously making things better, right? And then you have to continuously test on whether the changes that you add to the stage of the stuff that you deliver right now, if these changes having a positive or negative impact. So for instance, it's a great product, everybody likes it, or a great feature, and now we're making modifications to make it more lean, to make it more resource efficient. So now we need to continuously test that every change we deploy through the pipeline actually doesn't, let's say, increase the CPU utilization, memory utilization, because in the end, this would impact the business, because it's harder or more costly to run these features. So to sum it up, I think continuous testing, the word testing for me is not the best way to describe it. I think something more like continuous experimentation, continuous innovation is what we all want to achieve. And testing in the traditional sense has a place with it, but I would not want to use the word continuous testing for this.
You don't want to necessarily carve that out as a separate, discrete part of the process because it should be part of the whole process.
Exactly, exactly.
I would agree with that. And I love the concept of experimentation. Mm-hmm. And obviously the idea of locking down all the variables to the extent that you can, having fidelity across everything except for the change that you want to test, which is, of course, one line of code. It's removing all of Anders' 4-letter words from his comments that he puts in the code. He wants to make sure those are gone before we send them to production.
When I swear in Swedish, they're more than 4 letters, but you know.
Yeah, exactly. You guys are overachievers. So, Arthur, what are your thoughts on continuous testing?
So I think what I'll call him Anders, even though he wasn't troublesome, but or Andreas, but I think the idea of maybe a continuous assessment is really what he was saying, right? Where we're looking at the code and saying, is it ready? Is it ready? Is it worse? Is it better? And I think that is really the key to it, because if we look at continuous delivery, continuous deployment is kind of a holy grail for a lot of organizations. There are some that have achieved it. For most people, it's a thing that we're trying to reach toward. Yeah. So if we look at that, then we have these tests, we have this coding that's going on, we have the integrations going on, but at some point we have to be able to say, can I deploy this? Did I make it worse? Did I make it better? And that's where the continuous test, the continuous assessment comes in. And that's kind of the big difference between automation, you know, as a simple thing, and the continuous assessment, because the automation is just executing the tests. At some point, I have to look at them and say, is this okay? You know, I've told the story before, and I've told it for years, but 20-something years ago when my brother and I were working here on our parallel processing stuff, he wrote a test harness that would execute our tests, and we were starting to do automated testing. And he put a silly script in it just for fun. And if it said 80% of the tests passed, he'd say, go ahead, release it. And if 90% passed, he's like, yeah, it's great, you know, sell more. And if 50% passed, it said, go fire somebody. But that's really what we're trying to do, though, right? We did it as a joke 20 years ago, but now we're actually going to try and deploy based on this thing, making a decision without a brain stopping and saying, can I do this or not? So that's really what it's.
If 100% of the tests passed, did you fail then too? Because obviously you didn't write enough tests.
Right, and that can't be good, right?
Well, you know, that's the funny thing, and I've had that conversation with a bank before about increasing the number of tests and the number of failures, and they said, well, this is bad. And I said, well, do we know it's bad? I mean, did the number of tests go up, but the ratio of failure go up higher or less? And they looked at me with kind of a, you know, raised eyebrow and said, well, I don't know. And I said, yeah, neither do I. I need some more assessment.
From a performance management perspective, when the pages come back too fast, you know that that's a problem because that's a 404. One of the fast pages to return, or a 500, right?
I worry about radical change in any direction, right? Yeah. If something gets way too fast, I wonder that something got turned off.
Yeah, we had that problem once in our pipeline where all of a sudden the builds were kind of green, and we did notice that wait, we're running about 800 less tests today than we did yesterday. No wonder they're all green. Somebody had accidentally disabled a whole suite, so it's tricky.
All right, very good, Arthur. I cut you off there. Any final thoughts on that, or are we good?
I was just going to say, that's the problem where you have a continuous decision that, you know, before we looked as a human, said, tests are all green. Obviously something bad happened, not something very good. But now in an automation world, tests are all green. Let's go.
Interesting. So, but if I can sort of bring it up a level, I like the idea of that assessment, of continually assessing things. But the idea here is that test automation is more of a discrete part of the process, and that this continuous testing sounds like it's something that should just be folded into the overall commit and release pipeline. So it's an extension of CI/CD.
Yeah, I think so.
Yeah. Okay. Interesting. Javier, what are your thoughts on this?
Well, I believe continuous testing is a kind of regression testing killer. If you keep on testing, it's already have been said, if you keep on testing as much as possible, you're going to get higher feedback, and you are going to not rest assured that you are introducing defects, but at least you can have some confidence. And related to continuous delivery, that confidence is the only spot we can reach. We only can be happy whenever we have at least one level of confidence. It's not, I would simplify everything and just keep on testing the whole suite we've got. We have to control that nobody does bad things, but well, it's our main feedback besides of the product being buildable.
Yep. Very good. I love it. Andy Mann, what are your thoughts on continuous testing and faster feedback? Andy is now frozen. Perfect timing. All right. We will come back to that. One of the things that I thought was interesting that we had talked about was sort of the cost of these errors. And I know, Arthur, we've done a webinar on this where we talked about the cost of problems and the cost of finding them later versus earlier in the cycle. Does continuous testing, is that something does it help with that? Arthur's just smiling at me as well. Andy, you're back.
I am. Can you hear me now?
I can. We're having problems, folks. I don't know what's going on. There's a problem.
It is. It was all
weird.
I was all blacked out. But anyway, so I'll jump in and answer the last question if I can.
I would love if you would, please.
So I was saying the good-looking Andy was saying something earlier on about DevOps being about delivering faster with better quality, and I think that's the core of what continuous testing brings to the party. This idea of better software faster. It's velocity with quality. It's sort of easy to get software out fast if it's crap. It's sort of easy to get out good software if you've got a whole year to dump a feature. But doing it continuously with quality, I think, is the big thing. And when you get to a cycle of a virtuous cycle of continuous testing for not just functional quality, not just for even things like compliance, code coverage, but the one thing which I think is really important is getting that impact analysis as well. So when you talk about continuous testing, being able to test beyond release, I think is actually a really important part of that as well. So just extending that idea that it's not a discrete phase that you do continuous testing, then you stop doing continuous testing, and then you release it. I think that feedback loop that drives the innovation has to include that feedback from the post-deploy environment. In my mind, that's part of that continuous test loop as well.
Absolutely. Absolutely. Yeah. And that was my point earlier to Jeff around is continuous testing, does that include the releases into production? Some people say, well, yeah, we test in production. And as a matter of fact, you're being tested every day in production all the time. And if you can gather those insights and you can use them as feedback into the process, continually improve, I think that's a strong position to be in.
Yeah, I mean, I have actually one customer who they actually siphon off about 10% of their production server farm to do post-deployment testing. So they actually multi-home the traffic. They obviously do releases they don't do releases every 5 minutes or anything like an Amazon, but in a quiet time, like over the weekend, Saturday night, they'll hone off about 10% of their production server farm on a different subnet and actually feed traffic into both from production users, so end customers. And then, so the customer gets the response from the production environment, but that 10% is being used to test against performance and availability, resource utilization, response times, and just whether they actually deliver the response back. And so they're able to do this continuous testing even after deployment. It makes it a very powerful way to get quality into that system, because even when you do testing before production, you're not going to find all the problems probably, But if you do it on that real production-like environment, huge outcome in terms of quality.
Interesting. Yeah, that's great. And it's obviously there's some cost involved in that for them, but they've run the numbers and they figure that it's better to have a better quality product and spend a little extra money on infrastructure and banging away at it than not. So that's very interesting.
Yeah.
All right, man. Thank you. Hey, Anders, what are your thoughts on continuous testing and why and what
Well,
is
I think, you know, we all test in production. It's just a question of whether we admit that that's the case or not.
whether we meant to? Yeah.
Yeah. And I mean, the way I think about it is I think of continuous testing as kind of a strategy. The one of the end goals of that strategy is to make sure that we lower the business risk as part of our releases, so that when code gets exposed to customers or customers get exposed to code, whichever way that goes, that we minimize that risk. And that's the strategy. Test automation is a tactic that we use to implement continuous testing, you know, as much as possible. But I think the focus in continuous testing isn't so much on kind of the nitty gritty. Did this unit test or that unit test fail, or was the code formatted properly, and did we find bugs and all of those kinds of things? That's certainly part of the whole pipeline. But for sure, the thing that we're most concerned about is the business risk, not necessarily so much the technical risk. Are we ready to release? Can we take this to production now?
Right. Awesome. All right. So let's move on to our next topic. And we're talking about some of the challenges that we have getting to a place where you can do continuous testing. It seems to me that it's just an extension of continuous integration, but maybe I'm wrong on that. What are some of the challenges that you've seen with the folks that you've worked with trying to get to a position of continuous testing? And Jeff, I'm not going to start with you first because
rats.
Yeah, I understand that that's really problematic for you.
I wanted to go first this time.
You do?
No, go ahead.
Okay, I'd be happy to yield the floor to you, sir. But if you don't want it, then I will pitch it over to Javier, and I'll ask him what are his thoughts on this.
Well, we've been talking before. We want rapid feedback, and I believe that one of the first challenges is the amount of testing. We need to pay attention to coverage, functional coverage, or even line of code, but we have to pay special attention to runtime. It's not practical if we have a set of test suites that must be run for 4 or 5 hours because our feedback is going to be delayed too much, or at least it will slow the whole pipeline. So we have to approach in several ways. We should work on parallelizing tests, and we should work on writing proper tests without overdoing it. I think both problems impact the whole pipeline in a big way.
I can see that. Yeah, I think the idea of saying, well, I didn't want to put in too many tests, so I didn't test that because I didn't want it to go so slow, that may not be the right answer after a problem occurs. And the other answer is, well, the tests take too long because we have so many tests in there, so I just skip them. That also is not a very good answer. So I can definitely see how there's a conundrum there of balancing the coverage that you do, the amount of testing that you do, and the amount of time that it takes. So that's very interesting. So let's see. Andy Mann, what are your thoughts on some of the challenges of continuous testing?
Yeah, I mean, I think there's certainly that. I think part of it is the boundaries of where do you put the testing? Where do you say testing is done?
Well, we said
I actually think that
right? It's one big pipeline of gooey goodness.
Yeah, exactly. I mean, redefining what is done, and not saying that you're done just because you need to release. You can release when you're done. It's not the other way around. And so changing that mindset, changing that paradigm. I also think one of the other big challenges that I see, this is what my customers are doing, is you're running all this automated testing gets to a pace and a volume of output that it's really hard to to analyze and say that's done. And so being able to, as a human being, absorb all this output from multiple testing tools, black box from white box, static analysis, dynamic analysis, code coverage versus functional testing versus regression, all of this stuff. So automating the analysis of the testing, I think, is something that, that's where I'm seeing a lot of energy being put in now, so that you don't get that stop point. Sure, I've done automated testing, and now I've got to sit down for 3 hours and try and figure out whether it worked or not. So doing that analysis that then can feed back into automation tooling to keep that continuous flow going at pace. That, I think, is part of the challenge that I'm seeing at the moment.
Right. Yep. And then, like you said, understanding, it's great to do all the testing, but then if you can't do anything with the data, then what's the point of doing all that extra work and spending all that time? To Javier's point. Awesome. Thank you, Andy. Andy Grabner, what are your thoughts on this?
I actually want to add what Andy Man just said. I like this a lot. So basically, the problem is the time spent in diagnosing issues. And I think if we shift left further, actually going all the way back to the developers, and if we give them an easy way to say, I want to commit this code change, but first I want to make sure that I'm not introducing any type of regression. And if we do this on a developer by developer, on a check-in by check-in basis, the changes are so small that also regression analysis and root cause analysis becomes much easier. Now, a lot have been invested in tools to make automatic root cause analysis, easier and more, and also automatable. I know we sit here, we all represent different companies and building different products over the years. So we also invested a lot in making this easier and automatable. So I think that's a key thing. But the real big thing is shifting it left, making it as easy as possible for developers to get immediate feedback, but then also, I'm not sure if this is the right term, but shifting right. Shifting right means not only should I be interested in how is the feature doing in my development and test environment, but also how is it used out there. Because if I know how often my feature is actually used and how it's behaving right now, this actually gives me more insight into what is the potential impact that I make. Because if I working on a feature that is used by almost nobody, then it's easier to make a change. If it's a feature that is used by 80% of my users and it's business critical, then I have to even do more testing and I need to be even more careful. So kind of, making sure that we are shifting left, finding problems earlier, making it very easy and building it into the pipeline, but also pulling data from production so that we know what is the potential impact if I make a mistake. Because if I know the impact and the risk, I can think maybe more on what the changes that I'm going to apply. So these are kind of the things.
Very interesting. And so I like that whole idea of shifting left, obviously, but shifting right. So Anders, you had talked about this a little bit earlier in the year, maybe late last year, sort of ops dev, putting ops, designing all this stuff, but with the end in mind. And when you're thinking about, this continuous testing, and the fact that you are always getting tested, your metal, if you will, METTLE, is always being tested in production. You want to make sure that what you're doing up until production looks like what you're doing in production, right?
Yeah, I mean, the whole idea of monitoring, obviously, in testing or during testing, continuous monitoring. I guess I don't know if I coined that term just now, but probably not. But I think it's, why would you not monitor your code while you're testing it, right? Why would you not monitor your systems if you want to get as close to production as possible? That definitely should include all of those kinds of things. And I've told the anecdote, several times probably on this show as well of, we had a production issue that, turned out that it had thrown an error during unit testing. The test didn't fail, it just logged an error, but we didn't know because we were not checking our logs after unit tests for unaccounted for errors. So we changed that, and haven't had that sort of issue since. But again, that's you have to do monitoring and analysis of the data that gets thrown off as a side effect of all the testing that you do, and make sure that there's nothing unexpected in there. If you don't, that's a huge missed opportunity for finding problems before they get too far to the right. So.
Exactly. And again, I was going to ask Arthur this question because I know he and I did a webinar on this. The cost of finding those problems further to the right, it's not just a little bit more expensive. it's
terrific.
It's exceptionally more expensive. So I'm going to switch to you now, Arthur. What are your thoughts on some of the challenges of getting to continuous testing?
Sure. So, we've all kind of accepted at this point that the base is you have to automate everything, right? And then as like Javier started off and Andy kind of just built on it, is that we can't just do more testing, right? I mean, what we find is that the more tests we do, the more variance we have, the more noise that we have, the more time it takes us to analyze it. So I think what people are missing is that we really need to test smarter now, right? And that means when I'm looking at coverage, I have to say, do I need more tests to cover this? And when I'm looking at tests that are noisy, if I have a test suite that requires me to spend 3 hours to analyze it, that means I'm ignoring most of it. And let me make a really harsh suggestion here, right? Or maybe a modest proposal. A test that you ignore should be turned off, right? I would just turn it off, because at least you'll pay attention to other variances. And that's really important. And I think as we were talking about shifting left, I think that really is the key, is to understand when a change is made. If I have a ton of good tests that take a while, what's the minimum amount I really have to run? What will tell me that it's safe? I don't want to test everything, but I don't only want to test the line of code that I changed. I want to test the things that depend on the line of code I changed. And so getting that answer right, I think, is the key to letting you test smarter.
Is that the holy grail, though? Being able to know what to test based on what changed. And I would love that.
Maybe it is, and I hate to plug myself. I mean, that's one of the things we work on, right? That's one of the things we provide, right? Change-based testing panel that says test these things. So
interesting. And I was going to actually go out of this question. Saying that, given an unlimited amount of time, an unlimited amount of capacity for looking at the results, for collecting the results, would you still say you shouldn't test everything, even if it's stuff that you didn't look at? Or do you test everything you possibly can, but then apply something like a predictive analytics or a machine learning or something to it that allows you to, instead of having foresight to say, hey, you should test these things because you made these changes, where you can say later on, hey, because this developer checked in code in this section, in this module for this piece of this service, or that went on this kind of infrastructure, 90% of the times that developer does that, we have a problem in production, right?
So I think that the context is really important, right? Obviously, if this is a minor risk, I'm just going to toss it out there. If this is, safety critical, then I'm much more worried about running everything. But I think the more hidden danger there is that when we have noisy test suites, we have a tendency to ignore them. Right. Mm-hmm. And I use the example of a spell checker, right? You go write a document in our business and the spell checker just fires left and right on funny things, right? Mm-hmm. So if you put agile with a capital A, it's a failure, right? Even though you might intend it to be capital A agile at that instance. So I think that the thing I worry about isn't just the analysis, but the getting used to a bad test. And what I see is somebody has a test suite and they know that it's been passing at 80%. And they change a whole bunch of code and they run the entire test suite because they have time and money to do it, resources to do it. And it passes at 80% again. Well, the question I have is that even the same 80%? I have no way of knowing. So to me, the insidious bug is living with the noise because it makes us complacent in a very dangerous way.
Yeah,
right.
I mean, just if I can just jump in, this is very much like if anyone's done any bookkeeping, right? When you try and balance your ledgers and you get 1 cent difference, 1 cent doesn't sound like a lot, right? But it could be $1 million one way and $1 million and 1 cent the other way. And so you never really know unless you've got an actual balance, and maybe you've got to balance 2 or 3 times that you got it right. So yeah, that 1 cent difference can be huge.
It just tells you that there is error. It just tells that there is a problem.
Exactly.
Yeah, that is an interesting point. Jeff, we haven't heard from you on this subject yet.
Finally, I've been waiting for ages this time around. Well, the first thing I want to say is I think what we're all saying here is that testing is an engineering discipline like any other. And test design is a non-trivial activity, that we generate test debt just like we generate software development debt, that we have to learn, you know, to some degree, what do we need to test and what don't we need to test is something that we learn and refine over time. The other thing I want to say is I want to sort of, notwithstanding the stuff I said earlier about continuous, you know, design and testing and so on and so forth, I want to bring it much more down to earth here. The biggest objection that I see to continuous, whatever you want to call it, is, well, how do we keep up? If we're deploying 80 times a day, how do we keep up with our tests? What I see, an anti-pattern that I see too often, is testers doing manual testing and then trying to catch up often in the next sprint and writing automated tests and falling farther and farther behind. The anti-pattern that I see that goes along with that is when you do planning meetings, there's lots of discussion about development tasks, and the testers sit in the back of the room and they don't say anything and no one asks them any questions. As opposed to planning the test activities that, in terms of test automation activities that have to be done as part of the development work. The interesting thing that I see is there are really good modern test automation tools now, and you can write automated tests really fast. And you can write them a lot faster than you can write the code that they're going to test. So there isn't really an excuse anymore for not saying we're going to write automated tests as part of the same activity as writing the code. And when you do that, you stop falling behind. The other objection I see is, oh, everything's automated and Jenkins is going to decide whether the code should go to production. What about user acceptance testing? And where do you insert that? And no, we can't do continuous deployment. We can't automate all the way to production because we have to have this gate. And in my opinion, it's putting the gate in the wrong place. That where you really want to do user acceptance testing, ideally, is before the developer even checks the code in. If they've written some code that doesn't cut it from a user acceptance point of view, that code isn't ready to check in. Mm-hmm. And again, I've worked in situations where we got the product people and the design people and the developers working really closely together, and we had good local test environments. I've even worked with companies where we put Vagrant on the product owner's laptop so that they could test in a production-like environment as soon as the code was ready, and they could have a super tight feedback loop with the developer so that by the time the code made it into the Jenkins pipeline, it had already been accepted from a user feasibility point of view. So I think it's possible to make those things go away as obstacles. We often believe that they're obstacles.
Yep. Very interesting. Anders, I know you spoke earlier, but I never actually gave you a chance on this topic. Challenges for continuous testing, or?
I think the probably still the biggest challenge that I see people running into isn't necessarily even with continuous testing. It's just with test automation to begin with, which is, oh, we can't possibly automate that. There's no way. And I mean, I hear that on not a daily basis, but just about.
And oh, there he's back.
Yep. And it's just one of those things where you just have to push back on that. If anybody says we can't automate that, it's just not true. You can automate anything if you're properly motivated. So that's a big deal. Now you can't. Now the kind of the more intangible user experience. Did it take me 8 clicks to do something that should have taken 2 clicks? The design aspects of this, obviously, that's a different arena. And so I think rightfully pointing out that user acceptance testing is a little bit of a different horse of a different color a little bit. But the automation of almost all of this stuff is not a no-brainer. It's difficult. It is it is an engineering discipline. It is probably more difficult to automate some tests. In fact, I'm not even going to say probably. It is absolutely more difficult to automate some tests than it is to write the code that you're testing in to begin with. And in some cases now there are good tools that'll crank out simple unit tests and even to more complex ones and do fuzz testing and parameterized testing and those types of things. But rolling it all up to where it's, you know, kind of reliably doing what you need it to do is itself an engineering effort. In addition to the code, and you know, as we like to say a lot, you know, your path to production, you want to treat that as a feature of your product or a feature of your company or something, because that is, you know, that is how well your customers are going to, you know, think of your product when it gets out there. It's a huge part of it.
That's the only feature that really matters. It's your killer feature. It's getting the product in the hands of your people who are going to use it.
Yeah, nothing matters until that happens.
That's right. Right on. All right. So let's move on to our next topic, which is what are some prerequisites and some patterns for success when you're trying to achieve continuous testing? And I will start this time with Arthur Hicken.
Okay. So, you know, I think Jeff stepped right into it just a moment ago when he was talking about having local test environments, right? I mean, that's really crucial, right? If developers can't check something is working before they commit it, then you're asking for chaos in the whole, you know, machine that you have that's assembling and testing, right? They put some crap in there and you know, the whole machine blows up. So I think this having local test environments is a really super crucial step to getting high quality, you know, continuous stuff done. And on top of that, there's just a lot of, you know, Anders keeps saying engineering, and it's a word I agree with. I don't think it applies to software development, but I think that it should, right? I know an awful lot of people who will claim that they're a software engineer, and I still have to say, where did you get your software engineering degree? Right? Show it to me. Who's teaching that? Right? Because that's crap, right? But there's the curmudgeon, sorry. Yeah. He sneaks out from time to time. But I believe software can and should be engineering, and we should treat it like engineering. And often I see people who are reasonable engineers, maybe they have an EE degree, who'll behave like engineers when it comes to putting the right kind of wire in the building. And then when they go to write their software, they have this cognitive dissonance where they behave like monkeys. And that really is the nature of this continuous problem, that we have to be mature.
Is it because there's no cost to trying something? Is it because there's less of a cost of just trying something in software than in physical engineering? Is that sort of maybe?
Yeah, you know, with a bridge, you know, we joke about the dad telling his kid when you drive over the bridge and it says weight limit 10 tons, and the kid says, "Hey, Dad, you know, how did they figure that out?" And the dad says, "Well, you know, they drove a 1-ton truck over it, and that was okay. And so they drove a 2-ton truck, and that was okay, until they got to 11 tons, and it broke, so they tore the bridge down and built a new one." And we all laugh at that, but that's what we do in software. That's precisely what we do, right? And it's sometimes we can get away with it. It doesn't have the same cost, but I think that bringing more of an engineering view into it would put us in a much better place, because the fact that we can rebuild the bridge should be a benefit and not a risk to us, right? We should build a better bridge and next time do something in a more clever way.
Right, some more elegant, an elegant fashion. Love it. All right, very good. Let's see, Jeff Susna, back to you, sir. Prerequisites.
Well, I think I'm a big fan of local test environments. Organizations that have single point of failure dev and test environments drive me to distraction. With things like Cloud and Vagrant and Docker, it just seems like, why are we even still having that conversation? The amount of not just slowness, but quality problems that you get when you have polluted, congested test environments. It's just so much waste in so many directions. So I think that's a big one. You know, I'm not a very religious person when it comes to technology, but every place I go, every single client I have, one of the first questions I ask is, where's Vagrant? Why aren't you using Vagrant? And I find it a little depressing that everyone doesn't just say, oh, it's over here, dummy. Why are you even asking us that question?
Of course we're using this tool to help us make these machines, popping them out like whatever.
But on another level, an interesting one I find is we have all of this talk about feedback. Are we actually willing to pay attention to the feedback we get? And it's not actually as obvious as it may seem. I did a workshop for a company a while back, very, very mature Agile and DevOps practice. They brought me in because they were interested in my ideas and blah, blah, blah. And I wasn't actually sure I had much to teach them. And so I had them do this exercise where I had them think about linear processes and what happened when they turned them into circular processes. And they kind of chuckled at me. And they said, well, we don't really have any linear processes anymore. We've made them all circular. And I said, well, indulge me. Let's just do the exercise. And I'd broken the group into 4 small teams, and they went through the exercise. And 3 of the 4 teams independently came to the same conclusion, which is we're really good at collecting feedback, and then we ignore it. We throw it on the floor. And the lesson I've learned is that actually being willing to listen and change what you're doing and how you're doing based on the information you get back is actually a much bigger challenge than it may seem. And so if you don't have that, and again, if we bring it way down to earth, if you're not willing to stop the build when your CI server is red, then you're not actually a feedback-driven organization. Because you're not willing to say, the next thing we're going to do is not build this new feature. The next thing we're going to do is we're going to fix this problem because our feedback mechanism told us that's what we need to do. Yeah. So I think that's the most fundamental prerequisite.
Very interesting. Let's see, Andy Mann, I saw you nodding your head a lot there. What are your thoughts on this?
Yeah, look, I just think that last thing that Jeff said was so spot on. The idea that you've got to be able to respond to those tests and make the right decision. If you're a data-driven organization, saying that that done is Wednesday doesn't make any sense. Done is done, and if you're failing tests, you're not done. But part of that, I think, is also this idea that I think it was Anders was talking about, the idea of sort of risk segmentation. How much testing should you do before you get to done? It depends on, to a large degree, what are you testing? How important is it? How many users do you have? If it's what I like to call a crap application, something that departmental, not many people use, then maybe you don't need to do all the testing. But if it's something like your online web store where 2 minutes of downtime is going to cost you $300,000, then you need to do all the testing. So I think risk segmentation, test the right things at the right time is important. I really do think a framework for test analytics, if you will, because and sharing that framework, because everyone at every point needs to do some kind of test, whether it's a unit test, a functional test, a UAT, a performance test, even going into operations, a capacity test, even testing those innovation ideas need to feedback to the right people. So I think having the analytics that handle the level of volume that you get from automated testing, but also provide visibility to all the people that need it across the different segments of your delivery chain, so that everyone has the responses and the feedback all the time when they need it. And that enables you to go into it's sort of the Al Lowe method. I don't know if you ever played Leisure Suit Larry back in the day, but test early, test often, right? It's the old Al Lowe thing, save early, save often, from Leisure Suit Larry, yeah. But that means that if you've got this common framework for analyzing your test automation, then anyone can run automated testing and anyone can see whether that new application, that new feature is actually working. And lastly, like I said before, having a mechanism to get real world feedback from that application in prod so that testing really is continuous. You're testing the impact that you have on your customers or on your business or on your internal users, and you're able to marry that all together, because that for me is what continuous testing is about. Having all of those phases doing testing, everyone gets feedback, everyone has continuous learning.
Right. And being able to know what that segmentation you talked about is interesting, but again, if you think about sort of the machine learning future and the predictive stuff, does having too many tests, is that really a problem if you're able to have something figure out what the actual noise is and what the actual signal is, even among things that you think may not be signal. Again, if you have unlimited time and unlimited storage for all the results and does it make sense to just test everything all the time? I don't know. Maybe it doesn't. Maybe it does. I think the idea of knowing exactly what metrics and sort of the business impact that you're looking for, I think keeping that in mind is very good. But it'll be interesting to see as we move forward into our brave new future. And I just want to put it out there that I, for one, welcome our robot overlords. That it'll be interesting to see how much automation and how much testing we actually want to be doing all the time. So, yeah. Very good. All right. Javier, what are your thoughts?
Well, I'm going to go against the current. I believe local testing is important, but it's utopic. We aren't going to, as developers, we aren't going to get some really power horses to test our current development. Furthermore, there could be some third-party requirements that even with Docker in the playground, you aren't going to prepare a proper complete environment. I would go for having a full-powered continuous integration or continuous delivery environment whenever be a change, it doesn't mind how deep it is. A developer could commit its changes as soon as possible, just be assured that it at least compiles, and let the testing or the real heavy testing to an automatic environment. Another problem arises is that you have to pay attention to that feedback we are talking all this time. And you have to be ready to switch contexts because you are moving from developing and to reading those logs you are writing or your tests are writing. It's not easy, but I believe it's the better approach to our common problems. We are really restricted in environments, and it's the best way to use what we have.
Nice. Yep. Very good. All right, Andreas Grabner. What are your thoughts on this from some prerequisites or some patterns that you've seen that are successful?
Well, first of all, I think all that has been said, is obviously, it makes a lot of sense, and I agree with that. One thing that I think could actually make all this easier, but I know it's not easy for all organizations, is making application teams or feature teams or development teams responsible end-to-end for what they develop, including production. So that's what I see with some companies do, because if I as an application team that includes developers, testers, product managers, product owners, if we are responsible to make this feature a success, we first want to continuously test, maybe with some test user group, to figure out, is this the right thing before we actually go down a path and build something that nobody likes in the end. We want to invest a lot in upfront testing to make sure we are not delivering something that is total crap. And if it goes out into production, we want to keep monitoring and then taking the feedback seriously, because if you're responsible for it, then we should take it seriously. And I totally agree with what was said earlier. We have to listen to the feedback. And I think if you are, instead of having dev, test, and ops, right, the classical DevOps, if we have end-to-end teams that are responsible for everything they push through the pipeline, and if you make them responsible for the outcome, but also incentivize, hopefully, then also, if they do something good, then most of these problems will go away, assuming that the organization is ready enough to allow this type of model.
Yeah, the incentive of doing something good is you don't get fired. And then, of course, so that's the carrot. And then the stick, of course, is if you do something bad, well, then you get fired. It's so
it's not. No, it shouldn't be that cruel. No, I think obviously you have to. No, but I think again, everything that was said earlier makes a lot of sense. But I think this model at least worked in our organization and also works in organizations we work with. But it's a long way to get there, especially from an organization not punishing people all the time if they do something bad, but encouraging them to experiment something new, encourage them or allow them to fail, but learn.
So let me ask you a question. if, let's just say, somebody were to be promoting some code and your product were to have found a problem, would you have like a big UFO-sized thing that would shine a big red light in the middle of the room and make sure that everybody knows that somebody made a mistake? You wouldn't do something like that, would you?
Wouldn't be that something interesting, right? Our famous UFO. Yes, that's what I would do, right? That's a data radiator, of course. That's what I want to use, yeah? And that giving instant feedback, and if it's red, it tells you, oh, you better run and not go home.
And you have this data radiator. You've got the plans that are publicly available for people to go and print on their own.
Yeah, if you go on github.com, there's an open source project, search for Dynatrace UFO as UFO, unidentified flight object. We use this and we have it hanging in our office, visualizing the quality of the pipeline and the quality of the feature in production.
Amazing. Yep, a physical incarnation of your deepest, darkest quality problem.
And I think I actually have it here. Look at this. I have one version here. This is the UFO.
Very good.
It's not turned on right now because I'm just using it to promote it a little bit. But yeah, it's an open source hardware project that we use, and we hook it up with Jenkins to visualize the current state of the pipeline, and we hook it up with our production monitoring. So every feature is monitored from a production perspective and also from the pipeline. And so application teams can act in case something is red. That's the idea, right? You don't go home if you just broke the build and the UFO tells you that it's broken.
But it's an unidentified problem.
Yeah. Well, we have the monitoring products or whatever else you have to identify it very fast. Yeah.
Very good. All right. Thank you, Andreas. Anders, you're going to close the shop here. What are your thoughts on prerequisites and patterns that you've seen that have been successful?
So I think the UFO idea is awesome, fantastic. We actually used to use a red and a green lava lamp hooked up to X10 to signal when the pipeline was broken. But there's a better way, actually. Don't get rid of the UFO. The UFO, you still need it, but there is a better way to make sure that you don't have to sit there all night and wait for the build or the pipeline to go green again. And that's pre-flights, pre-commit, continuous integration, continuous testing. Something that we do in our own product and in our own teams, which is we have the ability to do a pre-commit build that takes you through as much of the software pipeline as you want to. If I'm making a quick bug fix and I just need to write a regression test for it, then I might run the smallest phase of the CI before I do the commit. And of course, the way it works is it runs the build as if you were doing a commit, just without the commit part. On the other hand, if I'm doing something like which I've been working on recently, I'm upgrading us to the latest version of Hibernate in the Flow product. It's been a year and a half since we've done that, and now there's some functionality that we want that wasn't there before. There, I'm not going to run the smallest, fastest pre-commit, pre-flight pipeline because I'm going to have to run this through pretty much everything, right? I'm going to have to run this through our integration testing, our system testing. It's going to have to run live on all the database vendors that we support, all of those kinds of things. So this is one of those changes where, you don't just kind of do that. But I am very, very confident that after my pre-commit continuous integration build succeeds, that when I do that commit, it's not going to break the build.
Right.
So I would say, even better than local testing, even more powerful than local testing, is the ability to do a pre-commit build where you essentially run through as much of your pipeline as you want without doing an actual commit. It's not perfect. It's not going to remove 100% of the problems or the errors. Nothing will. But we've seen this drastically reduce the number of broken builds that happen. And again, one of the key things is if it breaks, you're only breaking it for yourself, right? You're only making a mess for yourself that you need to clean up. But you have kind of the human factors bonus of, if it's 7 o'clock and I need to get home for my kids, recital, I don't have to stay because I didn't commit anything. I didn't break anything for anyone else. Yes, I'm not done as early as I want to be, but I'm not keeping other people from getting their work done by committing shit code and then going home. So that's a very, very powerful feature that we use all the time, and it'd be nice to see more of that, quite frankly. Now you can do that with branching and with distributed SCM as well, in terms of you can do a build on a branch and do a pull if it an automatic pull if it succeeds, or if you have the ability to reject pull requests and those kinds of things. So you can play games with the SCM system to get this up and going too. But having pre-commit builds is a pretty powerful piece of functionality that helps reduce the redness in the pipeline.
Very good. Well, folks, this has been a very interesting conversation. I thought continuous testing was just doing some testing, but apparently there's a lot more to it than that. I appreciate everybody joining. This has been a fantastic conversation. We will see you back here in 2 weeks for another episode of Continuous Discussions. Thanks, everybody.